In this lesson, we want to consider calculation examples of overall uncertainties. Calculating examples of overall uncertainties in addition and subtraction of quantities. So this is what we basically want to consider. Calculation examples of overall uncertainties in addition and subtraction of quantities. So I'm going to start with example 1. Example 1. Suppose you are given the cross-sectional area of a hollow cylindrical wall or hollow cylindrical pipe. This is the cross-sectional area of a hollow cylindrical pipe. So the hollow cylindrical pipe is D2, this is outer diameter. D1 is the inner diameter. So this is the hollow cylindrical pipe. So D2 is equals to 10,2 plus or minus 0,4 centimeters. D1 is equals to 8,4 plus or minus 0,2 centimeters. So this is D1, the inner diameter, D2 being the outer diameter. Then calculate the fractional uncertainty of the thickness of the pipe. Calculate the fractional uncertainty of the pipe thickness T. Right. So I want to call it the fractional uncertainty of the pipe thickness T. Thickness T is equals to D2 minus D1. That is the thickness of the cylindrical pipe. So overall uncertainty of T will be delta D2 plus delta D1. So this means overall uncertainty will be the uncertainty of D2 is 0,4, so it will be 0,4 of D1 is 0,2 plus 0,2. So the overall uncertainty will be plus or minus 0,6. That is the overall uncertainty of thickness. So fractional uncertainty of thickness. Fractional uncertainty of thickness T. Delta T over T, which is delta D2 plus delta D1 over D2 minus D1, which is going to be 0,4 plus 0,2. D2 minus D1 and D2 minus D1, which is 10,2 minus 8,4. This is going to be 0,6 over 1,8. So the fractional uncertainty will be 0,6 over 1,8, which is 6 over 80, which is going 0.3333. That is the fractional uncertainty of thickness of the hollow cylindrical pipe. So the uncertainty will be added to two uncertainties even if D2 was being separated from D1. So this is the actual thickness D2 minus D1. So the fractional uncertainty delta T over T is this one. Now moving on to example 2. Example 2. Example 2. We are given two lengths. Example 2. So we are given two lengths L1, which is 4,81 plus or minus 0,01 centimeters. Length L2, which is 1,19 plus or minus 0,02 centimeters. Then you have to calculate the percentage uncertainty of sum and difference of length. Calculate percentage uncertainty of percentage uncertainty of sum and difference of lengths. It's very simple. It's very simple. Let's go through this example together. Let's go through the example together. S is equals to L1 plus L2. So uncertainty of S is delta L1 plus delta L2. So we said earlier on we said L1 is 4,81 plus or minus 0,01 centimeters. L2 is 1,19 plus or minus 0,02 centimeters. So percentage uncertainty of S sum is delta S over S times 100, which would be delta L1 plus delta L2 over L1 plus L2 times 100. So this reduces to the uncertainty is 0,01 plus 0,02, which is going to be 0,03 over 4,81 plus 1,19 would be 6 times 100. So this will become 0.5%. 0.5%. That is the overall percentage uncertainty of sum of lengths. Then now I want to call it percentage uncertainty of difference. Percentage uncertainty of difference of lengths. Percentage uncertainty of difference. The difference is equal to L1 minus L2. So the uncertainty in difference is delta T, which is delta L1 plus delta L2. Percentage uncertainty of difference times 100, which is delta L1 plus delta L2 over L1 minus L2 times 100, which is going to be 0,01 plus 0,02, which is 0,03 over L1 minus L2 will be 3,62. If you calculate very well there, it will be 3,62 times 100. What do you get as percentage uncertainty? You're supposed to get 0.83%. Simple as that. Then our final example, which is example 3. Our final example is you are given an optical fiber strand, right? These are the dimensions of the optical fiber strand. So this is the outer cladding. Outer cladding. Inner core, another cladding, there's this small length D and another D, then there's this length which is T. So D, this thickness of the outer cladding and that thickness D, all of them are 0.17 plus or minus 0.01 micrometers. Then T, this thickness of the inner core, is equal to 2.83 plus or minus 0.01 micrometers as well. The question says, calculate the diameter of the optical fiber strand with uncertainty. Calculate diameter. Calculate overall, or simply calculate the whole diameter. Calculate diameter of strand and its uncertainty. Right. It's very simple. Right. This is how I'm going to do it. So the diameter of a strand will be D is equal to D plus T. So over uncertainty of D will be delta T there plus delta T plus delta T. So delta T will be the uncertainty in T 0.01 plus another uncertainty 0.01. And uncertainty in thickness is also 0.01. So the overall uncertainty will be plus or minus 0.03. Then G will be 2G plus T, which is 2 times 0.17 plus 2.83. If you add this properly, you're supposed to get 3.17. So D and this uncertainty will be overall diameter and this uncertainty will be D plus or minus delta D, which is 3.17 plus or minus 0.03 micrometers. This is basically how we calculate overall uncertainty.